All right, it's 10:30. Welcome everybody. We just want to make a note that today's session is being recorded. Well, good morning everybody and welcome to today's webinar, Health and Safety Awareness for Veterinary Clinics in Ontario. My name is Jack Minix. I'm a Consulting Services Manager at Workplace Safety and Prevention Services, and I'll be your host for today's Safety Connection. Now, before we get started, just have a few housekeeping notes. We'd ask if you would take a moment to complete this optional survey. There's a link in the chat. It's just a few questions and will assist us to build demographic information about those who attend our Safety Connections. Thank you in advance for taking the time to fill this out. And now I'd just like to guide you through some webinar housekeeping before we begin. First, your computer audio is recommended for this webinar. However, if needed, phone conference is available through the numbers in your email invite. We do recommend that you mute other devices in order to avoid distractions. Your microphone will remain muted throughout this webinar, and you will not have the ability to turn your camera on. The Microsoft Teams platform includes some engagement features shown on this slide. Please use the reactions icon as shown to react during the webinar. If the presenters do include a poll in their part, you will see a poll open in the chat and on screen. Choose your answer and click submit. You may send your questions to us at any time during the session through this chat feature. The chat can be accessed by clicking on the speech bubble icon on your screen. But please note, we will also have time at the end for a question and answer period of approximately 15 minutes at the end of this presentation. So if you have additional questions, we'll be happy to take them then. Just a note on some accessibility features. You may wish to turn on live captions in Teams, which will transcribe your voice to text or our voice to text. To turn on this feature, click on the more or the three dots or the ellipses button, select language and speech from the menu, and then turn on live captions. You also have the option to view the content of the webinar in full screen mode. The full screen option can be accessed by selecting the ellipses or three dots and then selecting full screen from the menu. If you have any technical difficulties during the presentation, please send us a message in the chat. And if you can't access the chat, please respond to the meeting invite email that you received from Safety Connection. And finally, just a few notes around our goals for today and for the Safety Connection. Our first goal is to learn, share, and discover what is of value to you. Second, to stay in touch and virtually connect with industry peers. Third, to evaluate or to facilitate an exchange of best practices within your sector or organization. And finally, to provide you with an opportunity to attend this session from your personal workspace. And now it's my pleasure to introduce today's speakers, beginning with Kristen Hoffman, Specialized Consultant Agriculture at Workplace Safety and Prevention Services. Kristen brings a passion for agriculture and commitment to health and safety through her role at WSPS. Kristen started her career at the former Farm Safety Association and, combined with her time at WSPS, has been a consultant for 18 years. Kristen supports firms through a collaborative and innovative approach. She's a registered kinesiologist and her family operates a farm in Southern Ontario. Now, Jae Young Lee. Jae Young is a health and safety consultant specializing in occupational hygiene at WSPS. She joined the organization in 2023 and has been providing occupational hygiene consulting services such as chemical and noise exposure assessments, designated substances assessments, and program development. Prior to joining WSPS, Jae Young worked as an occupational hygienist in the nuclear industry, as well as the railway industry. She has a master's degree in public health from the University of Toronto and is a certified industrial hygienist, or CIH. Lynn McDonald, MSc B.Ed, CRPA, is the Manager of Training and Liaison Scientist at the Radiation Safety Institute of Canada. Her scientific training took place at the University of Prince Edward Island and the University of Toronto and included research projects in condensed matter physics, nonlinear pattern formation, and biophysics. Her educational career includes adult and public education, as well as public school administration. At the Radiation Safety Institute of Canada, Lynn coordinates and teaches courses in radiation safety. She manages the e-learning site and hosts the Institute's free webinars on a variety of radiation safety topics, amongst other things. And finally, Madeline Fedorowicz. Madeline is currently the Senior Manager of the Ministry of Labor, Immigration, Training and Skills Development's Radiation Protection Services, where she has served for 15 years. Madeline began her career at the ministry as a radiation safety inspector before transitioning into leadership roles. With over 2 decades of experience in the radiation and nuclear industry, Madeline's work spans the research, healthcare, and regulatory sectors. Her expertise includes managing a radioanalytical laboratory, conducting environmental radiation monitoring, delivery safety oversight, and training at nuclear research facility, and performing quality assurance testing on radiation therapy equipment used in cancer treatment. Madeline holds bachelor's degrees in engineering, physics, and human physiology, and she's a licensed professional engineer in Ontario. So welcome to our speakers. Welcome to everyone who joined us today. I'm now going to hand things over to our first presenter, Kristen Hoffman, to begin today's Safety Connection. Kristen, I'll hand control back to you. I will be monitoring the chat in the background. I'll pop in if anything urgent comes up, but otherwise I'll be back at the end to take everyone's questions. Thank you very much.
Thanks so much, Jack. And once more, welcome everyone. Thanks so much for joining us this morning. In this session, we have a few points of conversation. Workplace Safety and Prevention Services, or WSPS, in collaboration with the Radiation Institute of Canada, as well as the Ministry of Labour, Immigration, Training and Skills Development, or MLI-TSD, have come together to share some insight on the responsibilities and expectations within veterinary services. Throughout our conversation today, we will explain the occupational health and safety system in Ontario, review some of those compliance requirements related to the Occupational Health and Safety Act and regulations as workplaces with employers through to workers, share best practices for health and safety in veterinary services through effective management of hazards. In particular, discuss radiation safety with insight from Lynn at the Radiation Safety Institute. As well, we will share some of the resources that are available for you through each of these organizations in collaboration. And as our host has suggested, there will be an opportunity for questions and answers with all of the speakers in this session. We welcome you to use the chat throughout the session to save those questions, and we will be sure to provide those answers or engage and follow up with you to provide those answers after the session. Ontario's occupational health and safety system consists of different partners. 2 of those represented within this session: the Ministry of Labour, Immigration, Training and Skills Development, including Radiation Protection Services, as well as the Health and Safety Association, Workplace Safety and Prevention Services, available to support you with those compliance requirements. We also have the Workplace Safety and Insurance Board, and we do acknowledge that veterinary services are not required to be registered with the WSIB. However, coverage is available by application. These partners work together in Ontario to prevent incidents and losses in workplaces specifically, ensure that we have controls in place to manage exposures that may result in injuries, illnesses, and fatalities. And each of these partners as well work together to support goals of the occupational health and safety system strategy to ensure that prevention. A little more specifically on each of these partners, and in particular, MLI-TSD. This ministry oversees and coordinates the occupational health and safety system. Within the MLI-TSD, there are roles who create and lead strategy for prevention. Specifically, that may involve setting requirements through legislation for both employment standards as well as health and safety, and providing resources to workplaces, employers through to workers in Ontario. The MLI-TSD may be contacted via phone as well as their website. The ministry does have a health and safety contact center that is available for information and support 24 hours a day, 7 days a week throughout the year. The WSIB, as mentioned, may not be a relationship that you do have within veterinary services, as you are not required to be registered likely. However, the WSIB does administer a no-fault insurance system for workplaces, employers through to workers in Ontario. By application insurance is available for veterinary services. And through the website listed, certainly more information is available, and we are happy to provide that to you following the session as well. Health and safety associations in Ontario are designated by the prevention system with the mandate to support employers through to workers for prevention of incidents and losses within workplaces. Workplace Safety and Prevention Services, WSPS, generally supports those within the agriculture, manufacturing, and service sector. And certainly veterinary services crosses a few of those descriptors, from large livestock that may be a part of your practice by way of agriculture through to the service that you are providing to your clients and patients. We are certainly available to support you through consulting, training, and other solutions. You will receive resources following this session, and I invite you as well to note that we may be contacted by phone as well as through our website as listed on the screen. WSPS is one of a group of health and safety associations. Others that you may be familiar with include Infrastructure, Public Services, Workplace Safety North, and some other partners that focus in on employer as well as employee-specific support. Once more, these organizations work together in collaboration in the province to provide our employers through to workers with the support they need to not only ensure compliance with requirements, but also ensure that protection of people and other important aspects of your businesses. Now, a primary part of the role within the MLI-TSD and WSPS is to support you in the understanding of those compliance requirements. So to begin, we begin with the Occupational Health and Safety Act, which sets out those minimum compliance requirements for health and safety in workplaces in Ontario. It does begin some discussion on procedures for managing hazards, as well as the roles of the ministry and health and safety associations. In this province, where we do have a relationship of employer through to employee, we would describe as a workplace, the Occupational Health and Safety Act is applicable. And the foundation of that legislation is what we describe as the Internal Responsibility System. This is a system that sets out duties or responsibilities, as well as rights for individuals within workplaces. There are expectations for managing hazards, as well as responding to incidents that may occur. Roles that we have in place in the workplace to fulfill these requirements include that of employers, those who have the greatest authority and responsibility within the workplace, who employ one or more workers, as well may contract for the services of one or more workers. Supervisors, next in that level of authority and responsibility, that have charge of the workplace or authority over a worker. And workers, all of those who perform work or supply services within the workplace. The expectation in this system is that we do communicate and share information from employer through to worker, worker through to employer, with that vital link of their supervisor. When we see something, we say something. And when we understand there is something that may result in an incident or loss, we take action, in particular as an employer and supervisor, to mitigate that risk. Now, we also have the role of a health and safety representative or joint health and safety committee that ultimately evaluates how well our internal responsibility system, our level of compliance, is within the workplace. And where there may be opportunities for improvement, we'll make those recommendations to the employer. Now, some of the specific duties outlined within the legislation for our employer are upon this screen. As mentioned, an employer has the greatest level of authority, accountability, and responsibility within the workplace to ensure that all individuals have the information, equipment, instruction, supervision, training, and understanding necessary to perform their work in a healthy and safe way. Employers must appoint competent individuals as supervisors, ensuring that those individuals have the tools necessary to provide that communication, information, and training to those who will perform the work or supply services. Now, of course, there are some more responsibilities specific upon this screen and beyond that include points such as the development of policies and procedures, the establishment and support of the health and safety representative or joint health and safety committee, and a general duty to take every precaution reasonable in the circumstances. You will know the work and workplace the best, recognizing where there may be risks and implementing through development, communication, and evaluation, effective controls to mitigate those risks. Now, next, as mentioned, is our supervisor that will often put into action some of those responsibilities of our employer, ensuring that a worker does have the tools they need to perform their work in a healthy and safe way, and ongoing evaluation of that performance to correct along the path as necessary, as well as reinforce. And also our supervisor has that same general responsibility to take every precaution reasonable in the circumstances for the protection of a worker. Workers, of course, have their set of responsibilities to be familiar with as well, which may be summarized as to work in compliance with the requirements that have been set out, both within legislation as well as by their employer in their workplace, which in simple terms means to follow the rules that the clinic or practice has established for protection of all individuals within the workplace. And one of the important parts in the role of a worker, given that there are many eyes and other senses that may see something before a supervisor or employer, is to report that information. Where there may be risks that a worker is familiar with, that duty to share that information so those risks can be mitigated. Important to note that in addition to duties, workers do have rights within this legislation, which involve the right to know about those type of risks in the workplace and how to manage their exposures, the right to participate in their health and safety program, which may be through the report of information and hazards, as well as a member of the Joint Health and Safety Committee or as the health and safety representative. and the right to refuse work that is unsafe, that may result in that loss within the workplace. Another point to note, as mentioned, a workplace that may require a health and safety representative or joint health and safety committee is described within the legislation based on the type of work and number of workers within the workplace will prompt the requirement for either that one worker as a health and safety representative, or perhaps a committee that involves both employer or management and worker representatives. And as we see, as the number of workers in a workplace increases, so too do the number of individuals required to fulfill these roles as health and safety representative or joint health and safety committee members. Beyond the Occupational Health and Safety Act, important to note that there are regulations made under the Act that are applicable for veterinary services, including Regulation 297 that sets out requirements for basic occupational health and safety awareness and training for those in the role of supervisor through to workers, as well as some other particular topics such as the Joint Health and Safety Committee. Noise, notices and reports, which sets out requirements for the notification of events or incidents, including incidents related to X-ray safety, where information must be provided to the MLI-TSD, Health and Safety Representative, or Joint Health and Safety Committee, and potentially others. Naloxone kits, exposure of a worker to biological or chemical agents, the Workplace Hazardous Materials Information System, or WHMIS, as well as X-ray safety, which we will explore further. A few important guidelines to note to support you in addition to the legislation. The MLI-TSD has prepared a guide to the Occupational Health and Safety Act to further explain those compliance requirements. A guide for health and safety committees and representatives, which outlines their functions as well as tools to fulfill their roles. Application for registration and installation of an X-ray source, as well as reporting workplace incidents and illnesses. Now, to prevent incidents that may result in injuries, illnesses, fatalities, and even property damage as losses, it is essential to effectively manage hazards within the workplace. And to take us through that conversation, I will welcome Jay Young to discuss hazards and their effective management. Thanks.
Thank you, Kristen. So managing hazards is essential to prevent injuries and illnesses and contributes to a healthy and productive workplace. Hazards exist in every workplace, from vet clinics to manufacturing facilities. And some hazards are more common to almost all workplaces, while others are workplace specific. Every workplace hazards can fall into one of the 6 identified hazard categories here on the screen. So chemical, physical, biological, MSDs or musculoskeletal disorders, psychosocial, and safety. Some common hazards that you may face when working in veterinary clinics may be chemical hazards, which includes toxic substances that can cause harm and adverse health effects. And they can come in many different forms, such as gases, vapors, dusts, and fumes. And there's also biological hazards, which includes living organisms that cause illnesses or disease to humans, such as bacteria, mold, and viruses. And MSDs, and this refers to any injury to any part of the musculoskeletal system through force, repetition, and awkward postures. It's interesting to note that this is the most commonly claimed injury here in Ontario. And there's also radiation hazards. So radiation refers to the emission of energy from a radiological source that can cause health effects by exposure to ionizing or non-ionizing radiation. The topic of radiation hazard and safety will be addressed more in detail in the later slides of today's presentation. So I have a quick chat question for you. So in the chat, if you could please enter some examples of hazards that you can think of in your workplace. And these hazards could be some disinfectants that you use, potentially some ergonomics. Any ideas are welcome in the chat. Animal bites, absolutely. Those would be a big one, especially for your workplaces. Sharps, absolutely. Needles that you may use. Bleach, yes. Bleach could be used as a disinfectant chemical, and absolutely they can have their own health effects as well. So those are some great examples that you provided. So as we can already see, there are different hazards at your workplace. So to manage this effectively, you can follow what's called the RACE model. So RACE stands for recognize, assess, control, and evaluate. And it is a process used to manage hazards in the workplace. And the circle that you see here represents the continuous cycle of hazard management. Now let's discuss each step in more details. So the first step is to recognize what hazards are present at your workplace. So here are some ideas on how you can do the recognize step. You can refer to SDSs or safety data sheets of the chemicals that you use at your facility. Safety data sheets are a wealth of knowledge that will provide you information on the hazardous information on the specific chemical that you use. You can also look at the different training that the workers currently receive. So for example, on how to handle biological hazards, how to do proper animal handling. So looking at that current training. And also for the sharp tools that you use, how are you currently managing the use and disposal of these sharp tools? So as you can imagine, there are many different information you need to gather to recognize hazards. So consulting with all different parties involved is very important, which includes supervisors, workers, as well as health and safety representatives and or JHSC. You could also reach out to the supplier as well, as they may be able to provide more information that you currently do not have. The next step is assessing the risks posed by the hazards that you identified. So when you're conducting a risk assessment, it is important to collect all relevant information. So for example, review your current process from start to the end, description of tasks, so how you're handling samples and or animals, whether there is a designated areas for certain tasks or is it performed on an open benchtop, for example, the frequency of exposure, so how many hours per week are you doing that specific task? Is it performed for most of your shift versus a short term? So these are all the different information you want to gather for your risk assessment. Next, we look at the control step of the RACE approach. So once we have identified our hazards and their associated risks, we need to control these hazards through various means. Now, using the reactions feature on Teams, please give me a thumbs up if you have heard the term hierarchy of controls. Is this a term that is familiar to? I see, yes, awesome. I see lots of thumbs up. That's great. For those of you who may not have, the hierarchy of controls measures from the most effective to the least effective. So at the most effective control, we have elimination, which is the removal of the hazard from the workplace. Then we have the substitution, which is the replacement of hazardous materials, equipment, or processes with those that are less harmful. Then we have engineering control, which uses physical and engineering methods to eliminate or minimize a hazard. So an example could be a fume hood. Then we have awareness, which could include when the workers will see or hear a warning system to warn them about the hazard. And then we have administrative control, which uses administrative or management involvement in order to minimize worker exposure to the hazard. So policies, procedures, and training would fall under this control. And lastly, we have the least effective control, which is personal protective equipment, or PPE. And it's any device that's worn or used by a worker to protect them against hazards. So examples could include gloves, lead shielded gears against X-rays, as well as respirators. Now, it is important to remember that a combination of controls, such as combination of engineering, administrative, and PPE may be required to reduce the risks to an acceptable level. Once you have implemented controls, their effectiveness should be evaluated to ensure that these controls are working and effective, you are reducing the risks, and have not introduced new hazards at your workplace. So check in with your supervisors and workers and see if they are happy with these new changes. And of course, always consult your health and safety representatives or Joint Health and Safety Committee on these new controls and evaluate their efficiency. So here are some examples of how race can be applied to different hazards that may be present at your workplace. And please note that this was done at a high level for purpose of today's presentation, and you likely need more thorough and detailed information for your specific workplace. So let's go through the 4 hazards that were mentioned earlier. And the first hazard we have here is chemical hazards. So of course, as a first step, you want to recognize what chemical hazards there are. So as mentioned, you can look at safety data sheets or SDSs and look for the hazard identification. Or you could also look at the labels that are present on chemical containers. You can also look at the current chemical inventory and see what chemicals you currently have at your facility, and see if you have a chemical purchasing process. How are you currently managing which chemicals are brought into your workplace? So now moving on to assess, we can look at the amount and frequency on how often you use these chemicals. You can also look at the physical state of chemicals. So for example, when you have a chemical that is solid, it's very unlikely that it may become airborne. However, if you have, for example, a liquid that you spray onto a surface, then you may create more mist and easy for your inhalation. So the physical state of chemicals is also important as well. The toxicity and health hazards. Consider that if a chemical is particularly toxic in comparison to the another. Investigate different ways of exposure. So for example, whether it could be inhaled, ingested, or you could be absorbed through your skin. And you could also perform a chemical exposure assessment. So this is where occupational hygienists, such as myself, may provide assistance with. So we can do a chemical exposure assessment to determine your current, the current concentration that the workers are exposed to certain chemicals. Then we move on to controls. So of course, you can eliminate and substitute chemicals. You can always use ventilation, such as fume hoods, when handling these different chemicals. Provide different trainings to workers, such as general as well as workplace-specific WHMIS training, and providing the adequate personal protective equipment, such as gloves or respirators. And evaluate the system. As part of evaluation, you can continue to maintain up-to-date inventory of chemicals as well as SDSs, conducting follow-up exposure assessments, and also establishing the chemical management system so you are aware of which chemicals are at your facility. Next example, we have biological hazards. So hazards may arise from the animals that you're providing treatments to, different samples that you may receive from your patients, as well when you are doing certain tasks such as administering vaccines, as that's where the risk of bloodborne pathogens may come in. And you want to assess these hazards. So again, how often and how long are you exposed to these hazards, the different types of samples that you receive, as they would pose different risks of infections or diseases, and review and assess your current practice for use, storage, and disposal of sharp tools such as needles. And of course, the controls that you may want to implement may include ventilation, so handling those samples under fume hood, providing trainings to your workers on topics such as proper animal handling, as well as zoonotic risks, having the appropriate storage box for used sharp tools such as needles to prevent any needle stick injuries. Using safety engineered needle is another great example of engineering controls. And of course, practicing that proper hygiene, as well as having appropriate PPE for your work is important control as well. And last step, evaluate. An example may include reviewing your procedures on needle safety, personal protective equipment, as well as biohazardous waste management. Next example that we have is MSD hazards. So of course, the hazards may come from handling animals that vary in their sizes and temperament. A larger and stronger animals will be likely harder to handle than smaller animals. And perhaps at your clinics, you are receiving shipments that are large and heavy in size. And you may also want to consider the postures that you're working in. Are you sitting at your desk versus standing up for most of your shift? So once this hazard is identified, then we need to assess. So you could perform an ergonomic assessment, which can be done by ergonomists. Consider if you're performing any repetitive motions throughout your shift, and whether you're working in awkward postures for a prolonged period of time, and whether you currently have any equipment or procedures to help you when you're handling these heavy materials. So as in control, we may implement ergonomic equipment such as height adjustable exam tables, so you do not have to bend over for a prolonged period of time. Providing trainings on proper lifting techniques as well as animal handling techniques. And also implementing frequent stretches throughout the work, so you're not in a static posture for a long periods of time. And of course, you want to evaluate as your final step. So the tools that you have implemented, are they appropriate for your work without introducing new hazards? And of course, you can perform a follow-up assessment for your ergonomic assessments. The last example I have for today is the radiation hazards. So recognizing that the sources of radiation that we have, such as X-ray machines, as well as nuclear medicine, may be the sources of our hazards. And to assess these, we can certainly perform exposure assessments. Also consider the frequency and length of using this different equipment, as well as medications. Consider the location of X-ray machine. Is the machine located in a central area where many people can have access to, or is it in its own designated area? And also consider what your current PPE requirements are when you are handling these sources of radiation. So as for control, of course, there is a training portion on radiation safety, performing the regular preventative maintenance of your equipment to ensure that these equipments are performing to the manufacturer's standard, and implementing proper PPE such as lead-shielded protective gear, as well as personal dosimeters. And finally, evaluate. So review the updated procedures and policies, which could include PPE program, as well as implementing the regular preventative maintenance schedule for the different equipment you may use, and of course, the follow-up exposure assessment. Now, I will pass it over to Lynn, who will provide more detailed information on radiation safety.
Thank you, Jae-Young. So I'm just waiting for the control to come over. I think it's there now. So with this, sorry, just one moment. There we go. So again, my name is Lynn McDonald. I'm with the Radiation Safety Institute of Canada, and we're an independent organization that provides free information about radiation, non-ionizing and ionizing radiation to the public and workers. So with this, we're going to take a look at X-ray safety and legislation. Now, there are other forms of radiation in veterinary clinics, such as those from nuclear medicine that are regulated by the Canadian Nuclear Safety Commission, and then non-ionizing radiation, for example, maybe there's lasers in use or infrared and such, that would be regulated by the province. The focus today, due to time limitations, will be just on X-ray safety. So what we're going to take a look at are different X-ray applications and modalities, X-rays as ionizing radiation, different health effects, natural sources of ionizing radiation, the radiation protection principles, and the bulk of the presentation will be on the current legislation in Ontario. So Regulation 861, some mention of Regulation 420, and talking about the RED Act and regulations. There'll be a brief mention of other hazards to consider and available resources that are out there with, in particular, to radiation. So in X-ray applications, they're in veterinary, they're used in many different ways. So there are diagnostic uses such as looking at bone and joint evaluations, doing dental assessments, thoracic imaging, abdominal imaging, reproductive support, and cancer staging, among others. They're used during procedures and surgical, preoperative and post-operative, but also with guided interventions such as placing stents and catheters, gastrointestinal motility, and foreign body retrieval. So they're used throughout veterinary practice. The different modalities that are commonly used in veterinary would be conventional radiography, using it for imaging purposes with single images, or computed tomography or CT scans, where you have a multitude of X-rays that are put together into a 3D image. Also dental radiography, your cone beam CT or CBCT, contrast radiography, and fluoroscopy, which is your real-time imaging used for placing stents and such. Now, in terms of why X-rays are a concern, this is going to be a very, very brief overview, but radiation itself is just energy moving from one place to another. And X-rays are a form of high energy electromagnetic radiation. They're created on purpose whenever you have high speed electrons hitting a target inside the X-ray tube called the anode. And when those electrons slow down or change direction, their kinetic energy gets converted into a photon. And if the photon's energetic enough, we call it an X-ray. It also can be converted into heat as well. X-ray tubes are very inefficient, so a lot of the energy gets converted into heat. So this energy is ionizing. And what does that mean? So as I said before, that energy is the ability to change matter in specific ways. If you get into physics courses, you spend a lot of time talking about energy. And then radiation is energy traveling out from a source, going from one place to another. And then ionizing radiation is radiation that has the ability, it deposits enough energy all at once to be able to strip electrons off of atoms or molecules, so they can break apart bonds in living tissue. And the IARC monographs that evaluate carcinogens, that they consider ionizing radiation as a type 1 carcinogen, so it's a known carcinogen. And because of that, it's a hazard in the workplace, right? And that's why part of why I was invited to speak on this. And as with every other hazard in the workplace, that you have to try to mitigate the effects. So when looking at X-rays, the primary beam is the one that is collimated when it comes out from the X-ray tube, and shielding is used to be able to have it go just to the area of interest in veterinary cases, to the animal patient. Because of the way that X-rays interact with matter, whenever you have a beam of X-rays hitting something, that there's X-rays that are scattered forward and there's X-rays that are scattered back towards and out from the side. So it tends to be at a lower energy. It would be as a result of interaction, so it's lower energy, but the scatter comes off. So the patient is a source of scattered radiation. And then even around the lead shielding, again, due to the properties of X-rays, that there'll be small amounts of radiation that can escape the lead shielding around the X-ray tube. Veterinary techs, people who are positioning animals, should never have their hands in the primary beam, but the shielding is what they need to have the lead PPE and things to protect them. So if anybody's hands are showing up in the image, that should not be permitted. So all of these three components, the primary, secondary, and the leakage, are all ionizing and must be considered as part of your radiation protection program. One thing about ionizing radiation is that we have no senses to be able to detect it. We cannot see, hear, taste, feel, or smell ionizing radiation. So we must rely on instruments to be able to detect whether it's present in the environment. There's two different major categories of instruments. One are dosimeters that measure the amount of dose, which is the energy being deposited into a person per unit mass, and the impacts of that. So with dosimeters, personalized dosimeters, people wear those, and it measures that individual's dose throughout a period of time before it's sent back for reading. And then there's survey meters, or another common category of instruments that do real-time measurements of what's happening in the moment. Now, in terms of health effects, again, this is a very, very brief introduction. In terms of health effects, that there are two main categories of health effects that could happen with exposures to ionizing radiation. One would be the result of acute exposures. And what acute exposures are is large exposures delivered within a short period of time, hours or days. Now, if you have very large doses arriving all at once, then you can have a large number of cells dying and get what are called tissue reactions. And these were formerly called deterministic effects, and now they're shifting over to calling them tissue reactions. And what's happening there is, because of these large amount of cells dying all at once, you see a different type of effect than just cancer. So this would be, burns, radiation sickness, things like that. Very, very uncommon to happen in Canadian workplaces. Now, the other thing that can happen is you can have cancer or risk-based effects that are more that DNA is being damaged. It's not a whole pile of cells being killed off all at once. It could be a single cell that gets mutated that could lead to a cancer. With chronic exposures, those are more common in Canadian workplaces, or this would be what is experienced in Canadian workplaces, where you have low dose exposure delivered over a very long period of time. So that would be your most common profile in Canadian workplaces with ionizing radiation sources. And it works a little differently, that what it does is increases the risk. It's not a definitive thing that it is going to happen, that a cancer will form. It's that it's risk-based. In a population of people that are exposed to workplace ionizing radiation, you would expect to see more cancer cases than one that is not. But it does depend on the amount of dose. Because of this, we're expected to keep doses as low as reasonably achievable. Because there's no known threshold, we cannot, as human scientists, do studies over large populations and say, let's give everybody a small amount of radiation and put them in one group or another and see whether we give them cancer, right? That's not ethical. So the assumption is, look, the studies that are done looking at populations like the World War II atomic bomb survivors, it's noted that the response of radiation dose to the risk of getting cancer is linear. So there are a few different mindsets out there as to how to interpret that and what to think about that. There are some that feel that there is a threshold under which we don't have to be concerned with ionizing radiation. There are others that feel that a little bit of radiation is actually a positive thing and primes the immune system to be able to deal with the mutations early on. But the commonly accepted and what's accepted in Canada is put out by the ICRP, the International Commission on Radiological Protection, is this linear non-threshold, that linearity that we see in populations like the World War II atomic bomb survivors who received much larger doses than what we receive in the workplace here in Canada, that linearity would go right back down to zero, so that any small amount would increase risk by a very small amount. So this is what, if you've seen the unit of millisievert before, if you do have dosimetry and you're tracking people's exposure, millisievert is measurement of the relative biological harm due to receiving a certain amount of energy per unit mass, so a certain amount of absorbed dose. And the estimate is that for every full sievert due to workplace exposure over a lifetime, that would increase the population's risk by 4%. Now, what does that mean? So about 25% of Canadians will develop a fatal cancer. Not to be flippant, but at some point, all of us will pass away from one cause or another. And the older we get, the more likely it is that cancer may turn up, because cancer results from repeated damage to the DNA that eventually isn't caught, that type of thing. If you look at the causes of deaths amongst Canadian, about 25%, it would be due to cancer. So if you had a population of people that never had workplace exposure to ionizing radiation, and then another population of Canadians that would have gotten a full sievert over their work span, you'd expect to see 29% of them to get a fatal cancer versus the 25 for the average Canadian. But please note that 1,000 millisieverts is an unusually large lifetime workplace dose. So these numbers, that's like worst case scenario. It's more typical that people would get possibly 1 or 2 millisieverts per year. And then over 50 years, then you're looking at more like at the 2 millisievert mark. At 50 years, you're looking at 100 millisieverts. So it's the risk would be much lower for the typical worker. One thing to remember is that we live on a radioactive planet, and our planet is traveling through radioactive space. So there is natural background radiation. And so one source of natural background is cosmic radiation, just to balance things out, right? It's a carcinogen, but it's also something that's there in nature. So we get radiation from the sun and from space. Canadians on average get about 0.3 millisieverts per year. It varies with altitude. The higher up you go, the more cosmic radiation you're exposed to, because our atmosphere is protective. So flying in an aircraft will result in a slightly greater exposure to cosmic radiation. Another few different exposures from natural radiation is that as I said, our planet is radioactive. There are elements such as uranium and thorium in our soil. There's 4 major ones, and they are there and a source of many different isotopes as their decay chain goes along. So these terrestrial radiations from radionuclides that exist in soil and rocks, we get about 0.35 millisieverts per year as Canadians, but again, it depends on where you live in the country. We also eat foods that have grown in soil, right? And so some of us eat animals that eat the plants that grow in soil. So we have radionuclides inside our bodies, such as potassium-40, which is common in bananas. Brazil nuts are another common food that has more radioactivity than average. I think the top 10 radioactive foods includes potatoes, for example. But if we tried to avoid potassium so that we wouldn't have any radioactive potassium in us, we wouldn't be healthy because we need potassium. So we have evolved to systems in our body to deal with certain levels of radiation and repair the damage that radioactivity does. So we get about 0.35 millisieverts per year from this internal dose. The largest source of radiation dose for most Canadians from natural sources is radon gas. And radon is a gas that is not it's not chemically reactive. It's part of the noble gases, and it's part of the decay chain of uranium. So when it forms in the ground, it seeps up through the ground, and where our buildings touch the ground, if there are cracks and such in the foundation, and depending on the air pressure in the house, it can be drawn into homes or workplaces, and then we breathe it in and out. But the next things that it becomes as it continues is it decays to the next few, it's called radon progeny, that these are solid particles that get attracted to dust and that they can remain in our lungs. And the radon progeny can actually give dose. It tends to give more dose than the gas. So the average Canadian gets about 1 millisievert per year. So we'd encourage people to test their homes and places where they spend a lot of time, like their offices and things, for radon gas. In terms of X-ray equipment, because X-ray equipment is something that's man-made and we use it, we don't put it inside our bodies, right? So nuclear sources that are natural or like they're happening and they're decaying away, if people work around things that are regulated by the CNSC, there's always a risk that you could get contamination get inside your bodies. With X-ray equipment, that's not a concern. Because it's external to our bodies. So what we can use to protect ourselves and workers are the radiation protection principles of time, spending less time with the X-ray equipment running or in the presence of the X-ray equipment, to put more distance between where the X-rays are coming out of and where you are positioned, and using appropriate shielding. Now, in terms of X-ray shielding, or just going back to distance for a moment, because this is something we answer inquiries from the public all the time. And one thing that has come up as a bit of an inquiry or a concern is that there may be a misconception out there that at some point at 4 meters or 3 meters, that some people think that the X-rays drop to zero. And that's not the case, that X-rays will travel out and they will weaken, but it's not that within that amount of distance, it will lower the dose, but it doesn't necessarily drop the dose to zero just by putting an extra meter or so away. It will lower it, but it doesn't drop off to zero within the typical spaces of an X-ray room. Now, in terms of shielding, that X-rays, they don't have a range because of the way that they work. And this is why we use them for imaging, right? Sometimes they can go right through. They actually have to hit a piece of matter in order to give up their energy, right? That they're just packets of pure energy traveling out through space. And in order to give up that energy, they have to hit an electron, or for very, very high energy X-rays that would be regulated by the CNSC, they might interact with the nucleus of the atom. But typically it's an electron that they're hitting. If they don't happen to hit an electron when they're going, they will go right through. And if they hit electrons in a certain way, the electron can convert its energy back into an X-ray again because they're high-speed electrons. Or it could be that only some of the energy of the X-ray gets used up in ejecting the electron and the rest travels off, and that's your scatter. But as they go through material and have more and more interactions, then the energy that they carry gets reduced. If you think of the whole beam as a bunch of little packets, as they go through, the energy of the beam gets reduced. Some of it'll get scattered. So PPE is a form of shielding, this lead PPE. It's just personalized shielding that someone is wearing. So if you're working around unenclosed beams, that typically you would expect people to be wearing lead aprons, their gloves, thyroid shields, and eye protection. The eye is sensitive to ionizing radiation and can cause cataract formation. So it's not so much a cancer concern, but the deterministic effect called cataracts or clouding of the lens of the eye. So these would be typical things that would be protecting the person again from the scatter coming off the X-ray patient. No one should be having their hands in the beam, the primary beam. We would recommend that hands-free imaging techniques be used as much as possible in order to lower dose to the technicians. Okay, with that, the short summary of different aspects of X-rays, we're going to now move into the regulatory piece. And one thing to note is that it depends on the energy of the X-ray source, who's in charge of regulating it. If the X-ray sources are above 1 mega electron volt, again, at that, when you get up over there, that the X-rays start interacting with nuclei and there's other effects that can happen, that they're within the jurisdiction of the Canadian Nuclear Safety Commission, or CNSC. X-rays under 1 MeV in Ontario are under within the jurisdiction of the Ministry of Labour, Immigration, Training and Skills Development, Ontario, under the Occupational Health and Safety Act, Regulation 861. Now, if it was human health care in Ontario, some sections of the Regulation 861 do not apply, and those sections are covered in Regulation 543 under the HARP Act. So if you have colleagues that are, or friends that are medical doctors or dentists or chiropractors, that type of thing, and they mention the HARP Act, that applies for human health care. For veterinary, it's solely Regulation 861 and then 420 for your reporting requirements. And then the other ones that I think it was Kristen had said, like for training and noise and things like that. But in terms of radiation, the HARP Act does not apply. And for enforcement, in Ontario, the enforcement of the X-ray safety regulations, the responsibility of the MLI-TSD, Fair, Safe, Healthy Workplaces Division, Occupational Health and Safety Branch, Radiation Protection Services, and Madeline Fedorich is here today to support with the questions, and she's from Radiation Protection Services, and they conduct occupational X-ray safety inspections. The definition of an X-ray worker in Ontario is any worker that has a possibility of receiving a radiation dose of 5 millisieverts or more per year from exposure to X-rays during the course of their job. They must be designated as an X-ray worker. So there are dose limits for your X-ray workers and your other workers under the Regulation 861. And so you can see it's basically, for the most part, a ratio of 10 times more for the X-ray workers, with the exception of the lens of the eye. And that was because there was part of it is that there's no understanding. It's fairly recent understanding that the lens of the eye is more sensitive to radiation exposure in terms of the formation of cataracts. Employers must register with the Director of Occupational Health and Safety at the MLI-TSD using an X-ray source at the workplace. If a registered employer ceases to have possession of an X-ray source, you have to notify the director. You must have a competent person. So employers shall designate a person to oversee the safe use and operation of X-ray sources. And to be considered competent for this designation, the person should have knowledge, training, or experience in the use and operation of X-ray sources and in radiation safety practices. And the Ministry of Labor, so the MLI-TSD, shall be advised in writing in the name of the person designated. So employers have to inform X-ray workers at the time their employment begins that in writing that they are employed as an X-ray worker. They have to let them know about the annual dose limits applicable to the X-ray workers. And if the worker is female, inform them of the dose limits applicable to pregnant X-ray workers. And you must maintain a list of all X-ray workers in your employment. Employers need to take every precaution reasonable in the circumstances to ensure the mean dose equivalent received by the abdomen of a permanent X-ray worker does not exceed 5 millisieverts during the pregnancy. Employers must provide each X-ray worker with a suitable personal dosimeter that will accurately measure the dose received by the worker. X-ray workers shall use the personal dosimeter as instructed by the employer, and the employer shall retain the X-ray worker's personal dosimeter records for at least 3 years. Now, just note, if you are looking through at Regulation 861, you'll note that sections 13 and 14 were repealed. They were the accident incident reporting sections. but they were not abolished or eliminated. They were moved to, in 2021, they were moved to a Regulation 420 under the Occupational Health and Safety Act, and it's called incidents where notice must be provided. So what it states in Regulation 420 is that where Regulation 861 of the Revised Regulations of Ontario 1990 X-ray safety made under the Act applies, there's mandatory notice when a worker has received in a period of 3 months a dose equivalent in excess of the annual limits for other workers, or an accident, failure of any X-ray source, or any other incident may have resulted in a worker receiving a dose equivalent in excess for the annual limits set out for X-ray workers. So that was back on a previous slide, those dose limits. So if people are getting over those, you need to let the ministry know. When you have X-ray sources used, you must have X-ray warning signs or warning devices posted or installed in conspicuous locations. And every X-ray source is capable of producing an exposure greater than 5 microgray per hour at an accessible point shall be labeled at its operating controls as a source of X-rays. Now, microgray is different than millisievert. It's just pure energy per unit mass, whereas the millisievert is looking at biological effects. So just make sure if someone's doing that measurement that they're measuring it in microgray and not microsievert. Where the exposure in an area may exceed 100 microgray per hour, access to the area shall be controlled by locks or interlocks, barriers and X-ray warning signs if the source is portable and mobile and is being so used. To ensure the dose limits are not exceeded, you need structural other shielding installed as necessary, and collimators or other suitable devices provided and used as are necessary to limit the dimensions of the useful X-ray beam. Now, there is a section in Regulation 861, it's section 16, that is specific to veterinary clinics. So the ones previous, they apply to everyone, and section 16 has mentioned just for veterinary clinics. So it's asking, if at all possible, that radiographic procedures are performed in a separated X-ray room, that air kerma, again, this is measured in gray or milligray or microgray, that there are air kerma meters that measure this. So it has to do with leakage radiation. There's requirements around exposure duration, that limiting the size of the dimensions of the useful beam, that if film cassettes are being used, that they shall not be held by hand. A lot of times now it would be a digital device that instead of a film cassette, but again, you wouldn't be holding that by hand. That the X-ray shall be restrained or supported by mechanical means where you possibly can. So again, hands-free if possible. And if it has to be restrained or supported by hand, a protective apron and gloves provide shielding equivalent at least 0.5 millimeters of lead shall be worn by the person doing that. And that you have to keep records of radiographic exposures, including date, kilovoltage, tube current, and duration of each exposure for at least a year. We would recommend from the Institute that you would keep them longer than that. Now, one act and regulation that you should be aware of if you're obtaining new X-ray equipment is the RED Act and regulation. And it sets standards for all radiation emitting devices brought into Canada or for the initial sale of new equipment within Canada. And so this includes for X-rays, microwaves, lasers, and radio waves. The regulator in this case is Health Canada, the Radiation Protection Bureau. Once you have the equipment in the country and installed, it falls over to the jurisdiction of the Ministry of Labor. But when you're bringing in equipment, you should be asking for to make sure that it follows the RED Act and regulation is intended for use within Canada. And your act and regulation set out evaluation guidelines for different categories of X-ray machines. Now, there are other hazards to consider with the fact that you have X-ray equipment in your workplace. So one would be your mechanical and ergonomic hazards, which come from handling, restraining animals, wearing lead PPE, as well as working in awkward positions when positioning the animals for imaging. So that can lead to strains, sprains, or other musculoskeletal injuries. There are electrical hazards. These work at very high voltages. And equipment is designed with safety features. Electrical energy can still be dangerous if systems are damaged or improperly serviced. No one should be working on the X-ray equipment unless they are trained to be a maintenance person for X-ray equipment. We also have biological hazards because veterinary staff are working directly with animals. There's potential exposure to zoonotic diseases as well as risks from bites, scratches, and contact with contaminated surfaces and equipment when performing the X-rays. So things have to be sanitized properly. Thermal hazards can arise because some components of the X-ray unit, such as tube housing or transformers, generate heat during operation and may cause burns if touched. In addition, overheating or electrical faults can pose a fire risk if not properly controlled. So again, proper maintenance of the equipment. There's moving parts in there. There's a lot of heat generated. There needs to be proper maintenance of the equipment to lower those risks around that hazard. There are hazardous substances to consider as well. These include toxic metals such as lead and cadmium within shielding or components, chemicals from film processing and older systems, and transformer oils, which in some cases may contain PCBs. These are primarily concerns during maintenance or disposal of equipment. Also, the high vacuum of the X-ray tube must also be considered during disposal. Finally, there are noise hazards. While the X-ray machine itself is not usually a major noise source, the combination of X-ray equipment, ventilation systems, and animal vocalizations can contribute to a stressful sound environment, especially if the X-ray room is really small. So in terms of resources, that you are welcome to visit our website, radiationsafety.ca, and there's a section up on the top right that says resources. We have a free information service, so you can write us at info@radiationsafety.ca, like 15-minute, half-hour answers, those are free. If it's something longer, like writing your radiation protection program, that's a consulting project, but we do have a free information service for both ionizing and non-ionizing radiation, and it's not just for workers in veterinary clinics, it's for any concerns that you have around radiation. We have free radiation protection plan templates for those workplaces that are under Regulation 861. We have free webinars, some with certificates. If people are part of professional associations, that you might be able to use those. Check with your association to see if webinars count. And that there's others that you can view and just have the resource material. We're trying to build more and more of these free webinar courses over time. There is an e-learning course that's available specifically for veterinary practices. So that would be a worker level course. And we do have X-ray safety officer courses as well in real-time training. We'd also suggest that you check out handsfreexrays.com. This is through Julia Baton, who is someone that promotes hands-free X-rays, and she has materials and stuff, a Canadian company that has things. And Julia is just someone that has come on a webinar with us and has been in contact with us for a number of years. So there is a webinar she did with us on hands-free X-rays, and her website has more information about that. So
Lynn,
yes.
Sorry,
Yep.
It's just Jack here. Just popping in with a question we had in the chat. I just saw your note about the information center. Do you know the answer to the question, who do we contact to dispose of lead gloves?
Or so it would be typically your different waste services. Like you have to follow the Environmental Act of Ontario and stuff, right? When you're disposing of lead. And there are a number of different companies that do take things that are environmental hazards. So I know that there's a lot of different universities and things that I know there's at least one person in here that works at a university that might know one of the services, but a lot of the major disposal facilities that if you contacted them, that they may have an environmental hazard disposal service, and you just be able to go through them.
Thank you.
Yeah. I don't want to promote, I know it's hands-free X-ray I did mention, but I don't know there's anybody else in the country that's doing that, but I don't want to pick one distributor over another. Sometimes your person can already do it if you're getting rid of sharps and you're getting rid of biohazards and everything else, they can probably take your lead gloves too.
Thank you.
Okay, thanks, Tara. Yeah, I knew Tara was out there somewhere. All right, so yeah, feel free to contact us if you have further questions. And I'm going to turn it back over at this point to Kristen.
Thanks so much, Lynn. On behalf of each of the organizations, we have resources to share with you just ahead of our period for questions. From the MLI-TSD, some of the resources mentioned include the guide, both for the Occupational Health and Safety Act and Health and Safety Committees and Representatives. More specific to hazard exposures, the resources on registration and installation of an X-ray source. Reporting workplace incidents and illnesses are some of the resources highlighted. Additionally, through the MLI-TSD website, you would find topics on animal handling through to WHMIS and the variety of topics in between. Radiation Safety Institute of Canada, as Lynn has shared with us, involves an information service to answer questions such as lead disposal, perhaps, plan templates for radiation protection, and for ongoing learning from webinars to e-learning courses and more formalized training. WSPS provides consulting on hazard-specific topics, as Jay Young shared, from designated substance programs to chemical exposure assessments, as well as respirator fit testing. And generally, our consulting solutions do involve your basic health and safety program development, from the basic policy through to communication, training, and other resources to support those basic compliance requirements. Through training, topics such as those for health and safety representatives, as well as joint health and safety committees, and then more specific to roles such as those in the role of a supervisor and due diligence strategies, or return on investment for those in the role of an employer or operator of businesses. Also available are conferences and networking events, further safety connections such as this session, many of those recorded and available for view following the sessions as well. Publications that you are welcome to subscribe to that often collect information from MLI-TSD and other officials, as well as our own resources to land in your inbox on occasion. And further resources such as those you may wish to view or download and use for your own: templates, checklists, videos, posters, and a multitude of others. Also to note, we do offer free support to workplaces that receive orders from the MLI-TSD. That said, available to support all workplaces with or without orders. Generally, the health and safety associations and WSPS in particular are in place in Ontario to support you with compliance requirements, as well as in your efforts for prevention of incidents and losses. Please do engage. If not yet, we will coordinate you with the most appropriate and often regional contact to support you. And with that, I will welcome Jack to facilitate our Q&A.
Thank you. If I could maybe get Jay Young, Lynn, come on camera, and Madeline, we'll take some questions. If anybody has questions, you can use the chat feature to type that out. That was great presentation. Thank you very much for the information. Lynn, you took me back to my physics days back in the... I was worried there might be a test at the end, but I think we're okay.
No, we're okay.
I forgot all about the unit of gray until today. Well, maybe I'll kick off the question period just with a couple of questions. And again, feel free to type in the chat. Kristen, if I am correct, we will be following up this Safety Connection Day with an email to all participants, which will include a list of those resources that you listed in the previous slides.
Yes.
So just everyone on the line, just keep an eye out in your email for that follow-up. And approximately 2 weeks after this webinar, we'll have the recording of today's session on our website for free download. So if you missed part of it or you wanted to share with anyone else, that will be available on our website. So Kristen, maybe I'll start with you with a question. If somebody on the line has more than one clinic location, would they need a health and safety representative or a JHSC at each of their locations?
A good question. And whether veterinary services or otherwise, generally, each location will be considered a workplace. And each location then, based on type of work and number of workers at each location, would establish their own health and safety representative or joint health and safety committee. That said, there is an opportunity to establish what is described as a multi-workplace joint health and safety committee. Now, that opportunity is through an application and conversation with the ministry to determine if it is appropriate, where we have multiple locations, to have one committee that would represent all. Generally, though, consider each of those clinic locations as separate workplaces.
All right, thank you, Kristen. Jay Young, maybe I can pick on you for this next question. It's a WHMIS question. Is this a common question that we get? I'm sure you're well versed in this. Is WHMIS training required to be taken upon hire and then again every year, or is it okay just to do it upon hire?
Right, and this is an excellent question because, like you mentioned, Jack, this question does come up every once in a while. So, regulation-wise, there is no frequency that's required to provide WHMIS training. However, as a due diligence, we would recommend to provide the WHMIS training on a regular basis, whether it being yearly or every 2 years. And also when you get the new chemicals at your workplace. So the workers who are handling those chemicals or other agents are familiar with those. And it's also important to remember, though, although there's no regulatory requirement on how often the workers need to take the training itself must be reviewed in consultation with the Joint Health and Safety Committee on an annual basis. So that was something I wanted to add to that question.
Thank you. That's great. Thanks, Jay Young. I saw you nodding, Kristen, so I think you concur. Lynn, maybe I could move to you for this next question. It just popped up in the chat regarding an X-ray room located in a fairly central location on our treatment floor where staff are almost always located while X-rays are being done. Are there specific requirements for the type of door that is on the X-ray room? Do you know the answer to that?
I do, but I'm thinking with Madeline here. Madeline, are you, that there are requirements for shielding and the plans must be approved by the ministry? So it's not specific, it's not going to be in the regulation, the specific type of material, but there's going to be a requirement for specific dose levels. So I'll let Madeline hop on there.
Thank you.
Sure. And as Lynn pointed out, the regulation doesn't specifically state that a door has to be made out of certain materials, but the door is considered part of your shielding. And it is during the application for an X-ray room that our engineer would review the type of shielding in that door to determine whether or not it meets minimum requirements. So the door that you have should be or is part of the overall shielding plan and would be evaluated.
Thank you. That's great. I just see one of our consultants, Tova, just popped in a comment around WHMIS for Stacy's question. So Stacy, the link there will give you some further information about our services with WHMIS. Madeline, while you're on, maybe I could ask you a question around what would be considered X-ray incidents, and when would they need to be reported, and how are they required to be reported?
There's two different types of incidences. One is where, let's say you've received your dose report back from your dosimetry provider, and you see that an individual has, let's say, gotten a dose greater than 5 millisieverts in a quarter. That needs to be reported. The other type of incidence is, let's say, there was an accidental exposure. Someone was in the room and the exposure switch was triggered, or somebody, let's say, was in a CT room and the machine was on, they didn't realize it, and you don't know how much dose that they got. You are required, I believe it is within 2 days, to report that to the ministry. The web link that was shared earlier, and that will come out to you, there is a link to the guide to the 420 regulation, and in there is instructions and information how you would report this. You can use a form provided by the ministry, or you can just include a written notice with certain information attached.
Great, thank you.
And I just wondering if I can go back to the earlier question about the X-ray room
Please,
in
yes.
a central location with the door. One of the things I wanted to add is when we evaluate the boundaries to the X-ray room, we're assuming that everybody outside the room is not an X-ray worker. So when we look at how much radiation dose they at most can be exposed to, we're considering non-X-ray workers. So we're looking at a very low dose rate. So as long as your floor plan has been reviewed and found acceptable by one of our engineers, you can be assured any workers working outside that room, as long as it's been built to what the requirements are in that plan, will not be exposed to X-rays above, I guess, their non-X-ray dose limits. They'd be kept as low as it's reasonably achievable.
Thank you. Speaking of doses, and I was wondering around requirements for dosimeters. Can you speak about who would need to wear a dosimeter in a veterinary clinic?
Yes, and as mentioned earlier by Lynn, we would consider an X-ray worker to be anyone who in the course of their regular work would be potentially exposed to more than 5 millisieverts per year. But we would also include anyone who works in close proximity to an open beam to be part of that category. So really anyone who works with an open beam, whether it be general X-ray or dental X-ray, they would be required to have a dosimeter.
Got it. Okay, thank you.
And sorry, one more thing. In Ontario,
Yep.
This is one place where we are different from the rest of Canada. In Ontario, the dosimeters the veterinarians provide should be head collar and worn on the outside of the lead attached to the thyroid collar. This is different from other provinces and jurisdictions in Canada.
Thank you. Lynn, can I ask a question around PPE, particularly like lead PPE? How would you recommend that it be checked, and how often would that need to be done?
So there are some guidelines out there in terms of papers. There's nothing specific in the regulation that says exactly how you must do it, but the general best practice is that you'd use imaging like fluoroscopy or imaging to look for holes. And there's certain size guidelines and things like that, and that you would do that once a year. So if people do have questions, I can send over some resources on like the papers. There's a number of different papers on that are available.
Thank you. Just a question around dose limits for the veterinary patients. Are there any dose limits for the animals that the veterinarians have to treat?
No. And even in human patients, there are no dose limits. That again, it's the International Commission on Radiological Protection has a system of radiological protection that they recommend. So they look into different types of things, and there's different types of exposures. One is planned as part of a workplace, things like that. And then there's emergency, but there's also medical. So if
Yeah.
there were limits to the amount of exposure you could give to radiation, it might limit the ability of medical practitioners and veterinarians to be able to use doses for cancer treatment per se,
Right.
right?
Right.
So
Yeah.
there's no actual limits for the patients, human or otherwise,
For the
because
patients. Okay.
yeah,
Yeah.
it's up to the medical professional, veterinary or human, to decide what they are, like taking a look at that, 4% per thousand millisieverts, how important it is that they get the radiation now versus the slight risk of cancer later on.
Yeah. We just had a question pop in around. So can you remind us from your presentation what was the lifetime dose for an X-ray worker?
It's not so much done lifetime, it's looking at year by
Okay.
year. So
Yeah.
if you were to get the maximum, of that 50 millisieverts per year every year and work for 50 years, you could do the math on that. But
Right.
I think Madeline's here. I don't wish to speak for the regulator, but I think most regulators, because of that ALARA mindset and keeping the doses as low as reasonably achievable, if they did see that workers were getting 5 millisieverts every year over a number of years, that the ministry would probably say that's not meeting the requirement to keep doses as low as reasonably achievable. But I'll let Madeline speak to that.
Sure. So there is no lifetime dose limit. As Lynn stated, we look at an annual dose limit. So if you're looking at the upper high limit, if you have a worker that has been exposed to millisieverts per year, that worker would not be allowed to take any further X-rays until their annual dose goes back down below the 50 millisieverts. But that being said, under the ALARA principle, the as low as reasonably achievable, which is in the X-ray regulations, we do require employers and workers to ensure that the doses they are exposed to as low as possible. And what is, I guess, could be considered normal for your practice would depend upon your workload for your X-rays, how many you're taking. Typically, we see an emergency vet that can take, hundreds of X-rays a week. We will typically see slightly higher doses on their workers than, say, a smaller veterinarian clinic that may only take a couple X-rays per week. So you need to look at your own practices and determine what's as low as possible. And as Lynn and other people have mentioned, hands-free is the best way to do this.
Great. Well, we're the time has flown by. We're at the end of our time together. I want to thank everyone for participating in today's session. I want to thank our panel for your presentation and your questions. Everyone that signed up will receive a follow-up email with some resources that are linked that we discussed today, along with a link for the recording of this session. Please share with any of your veterinary clinic contacts. Remember, we're all here to help, and please reach out anytime to the contacts listed in that email. Thank you, Kristen, Jay Young, Lynn, Madeline, and everyone for your time today. Have a great day, everyone.